first thing that we're going to need here is a balanced chemical reaction. So let's pick one. We're going to do something like the reaction here, ammonium oxalate, and it will react with silver nitrate to produce these two products. It will produce silver oxalate, and we're going to also have ammonium nitrate. Actually, I made one little mistake here. Let me modify our ammonium. Make sure that you guys put the 4 inside the parentheses and a 2 outside of it. So there's 2 ammonium on this side. There's just 1 on this side. I'm going to put a 2 out in front. That's also going to affect our nitrate on this side, so I'll put a 2 here. I see that means 2 silver. We've already got 2 silver. There's only 1 oxalate, 1 oxalate. So the balanced reaction here is 1, 2, 1, 2. This is kind of what we would face is if we have to convert one of these substances in grams to the other. In this case, we're going to have something like, in the event that we had, let's say, 74.530 grams of ammonium oxalate, C2O4, reacts. And what they end up wanting is how much of the silver nitrate would you need? The kind of information that's actually given to us and provided is a value that's in grams. And when you hear something like how much of, they generally mean mass. So we're looking for the number of grams of the silver nitrate. So going through this, the most important part that we identify right off the bat is our mole-to-mole ratio between them. The value here in front says 1 mole of ammonium oxalate will react with the value in front of the silver nitrate, 2 moles of silver nitrate. So what we have is 1 mole of ammonium oxalate will react with 2 moles of the silver nitrate. So we have that mole-to-mole ratio. We have the number of grams to start. So we're going to set this up. We need to go from the grams of substance A, which is this guy here, ammonium oxalate, and eventually we need to get into substance B. The route that we're going to take here is grams of A, grams of the ammonium oxalate, and we're going to go to moles of A, then we'll turn it into moles of B, which in this case we're talking about the silver nitrate, and eventually into grams of substance B. That'll kind of be our ultimate goal here. So the very first piece of info we're going to put is our given, so 74.530 grams of ammonium oxalate. And the first place we're going is moles of that same exact thing, moles of the ammonium oxalate. And down here, we get to copy our unit from above, because that's always the case. So I'm going to copy this unit, grams of ammonium oxalate. That gets copied right here. And we're going to put grams of the ammonium oxalate right down here. 1 mole goes on top. And for the number of grams here, when I have grams and moles or moles and grams, either way, I need to find that value from our periodic table here. So I'm going to try and do that relatively quickly. Really what we need to do is pull up a calculator. And so there are 2 nitrogens. So 2 times 14.007 plus there are 8 hydrogens. 8 times 1.008 plus 2 carbons. That's 12.011. And we're going to add 4 of the oxygens, which is 15.999. Hit enter. Looks like 124.096 grams. In this next place here, we've got those units taken care of. I need to copy moles down below here. So moles of the NH4 to C2O4. So we've done grams to moles. Now we need to go to moles of the second substance. So mole over mole. This is where we're going to use our mole ratio up here. This is where this comes important. We're going to have moles of the silver nitrate. We need to fill these values in. Those are based on our balanced equation way up here. 2 moles of silver nitrate react with 1 mole of ammonium oxalate. That's all we need to do for the mole-to-mole ratio there. Now this unit cancels with this unit. We've done that piece right up here. And we've only got one last thing to do. We've got to get 2 grams of the silver nitrate. And down here we're going to copy that same unit diagonally. So that's going to be our moles of silver nitrate. And just like before, whenever we have moles and grams or grams and moles, means it's the molar mass from the periodic table. So I need to quickly hop over to my calculator here and let's see. For silver, 107.87, there's just one of those, plus a single nitrogen plus 3 oxygens, 169.874 grams. So now we actually have to do the math for all of this guy. All right, 74.530 times 1 times 2 times this last piece over here, which is hiding, 169.874 equals, that's the number for multiplying everything across the top. Now I need to divide that by everything that is on the bottom. So I look at the bottom here, and because I have two values that are 1, really those aren't going to affect anything. So I really need to divide mainly by that value, that number of grams. Divide by 124. Let me type 4. There we go. This is 0.096. So our answer here is 204 with a whole bunch of numbers. So hold on, let's write that down really quickly. 204.0470, and that's going to be in this unit here, grams of the silver nitrate. And we'll double check back with our original value. We have 1, 2, 3, 4, 5 sig figs. This is a right 0, but it does have a decimal point, so that one will count. So we have 5 sig figs. I'll take these values, 1, 2, 3, 4, 5, cut it off right there, and then round up because that's a 7. So ultimately, the answer that I can report for our question up here, how much of the silver nitrate is needed, I can report 204.05 grams of silver nitrate is needed. All right, there you go. That's example number 2.